All right. Okay, hey, Rem, and who else? Just Rem?
Just Rem, I think.
Just Rem. It feels like we're missing more people. He must be like a very loud presence in this room or something.
He's
Oh,
very
Kellen.
loud.
That's right. See, we are missing more than just Rem. We're missing Kellen too. Okay. Those two must be our loud presences in the room. I don't know. Whew. Okay, so 4-4. We're gonna start homework or start notes for 4-4. We're gonna get about halfway through this. We did this in, I think, geometry. We would have done this a couple years ago. When we did like probability, our probability section. Okay, so multiplication rule. Here we go. I'm gonna go down to the multiplication rule basically says find the total number of possible outcomes from the how many options that you have. So like you might see this in when you're like arranging outfits. So if I say how many outfits can I make from 3 shirts, 5 pairs of pants, what else do we want? Socks. Let's do 2 pairs of socks. And let's just go with that, right? How many outfits can I make? So I can use the red shirt, I can use the leggings, and the fuzzy socks. I don't know, whatever. That's 1 outfit out of a total of how many? What do? Multiply those options together. 3 times 5 times 2 is 30 different outfits. Okay, 30 different combinations of what I could have, right? Okay, that same logic applies to like questions like example 1, although it may not feel like it is. Example 1 says, making random guesses for unknown 4-digit passcodes. Okay, whenever they say you have a passcode, 1, 2, 3, 4. I put 4 blanks there. I still do that all the time, every time. That's what I do. Each digit can be 0 through 9. And can you repeat or can you not repeat? It doesn't say, so we're assuming that we can repeat, right? So like my passcode could be 1111, right? Or it could be 4782. I don't know. That's 1 passcode out of a total of how many? All right, so now I have to decide how many numbers could go in that first spot. Right? 10 including 0. So 0 and then 1 through 9, that's 10 different numbers. So 10 numbers could go in this spot, right? How many numbers could go in the second spot? 10. And 10. And 10. So you could take 10 times itself 4 times. You could go 10 to the 4th power, which is 1 with how many zeros? 4 zeros, right? 10 to the 4th power is 1 with 4 zeros. So there is 10,000. Now it says, given that what is the total number of different possible passcodes? That's one answer. Given that all of the guesses have the same chance of being correct, what is the probability of guessing the correct one on the first attempt? 1 over 10,000. Now they ask it as a probability and it's 1 out of 10,000, which is like really, really, really small percentage, right? Yeah? Okay, yeah. Yeah, very unlikely to happen.
What if you couldn't repeat though?
If you could, that's a good question. What if you can't repeat? So like what if this first number was a 4? Now this one can't be a 4. So how many different numbers could it be? It could be 9 different numbers. And then after that one's chosen to be like, let's say a 6. Now this number can't be a 4 or 6, so you only have 8 different numbers, right? So then you would have to take 10 times 9 times 8 times 7. Mm-hmm. Yep. There's no really shortcut for that one. So good question. Okay. All right. Factorial. Do you guys know what a factorial is? Factorial has the like exclamation point behind it, right? So 4 factorial would be 4 times 3 times 2 times 1. Yeah. Do we remember factorials? I'll show you when this
like
is.
all the numbers leading up to that.
Yeah, and you're multiplying them all together. Okay. So like 13 factorial would be 13 times 12 times 11 times 10 times 9 and all the way down, right? Okay. Now, special cases. 0 factorial is actually 1. 1 factorial is also 1, right? So 0 factorial and 1 factorial are both 1. Okay, that's kind of a little weird thing that happens, okay? So factorial, they put that little exclamation point behind it. When would you ever use this? Let's say, I'm going to do an example off to the side over here because I like my examples better than theirs. Let's say we are lining up 6 people for a photo. How many ways? How many ways to line 6 people up for a photo? 1, 2, 3, 4, 5, 6, right? So like I could have Jace be first, or I could have Megan be first, or I could have whatever be first. I have 6 people that could be first. I have whatever, right? Okay, so as I do this, there are 6 people that can be chosen first. Let's say that it is Jace. Okay, now that Jace has been chosen, how many people could be in that second spot? 5 different people, right? Let's say that it is Megan. Okay, now we have only 4 people left to choose from for that third spot. Let's say it's Delaney. Then we have 3 people to choose from. Let's say it's Chloe. Woo. Then we have 2 people to choose from. Let's say that it's Hallie with a Y. And 1 person to choose from. Let's say it's Avalie. Okay, that's the order. That is only one order. Jace, Megan, Delaney, Chloe, Hallie, and Avalie. That's only one order out of a total of how many? 6 times 5 times 4 times 3 times 2 times 1. You can certainly type that into your calculator if you want to, or you have a factorial button on your calculator. I'm going to show you where it's at right now. 6 factorial. Okay? Find your calculator. Do you have a calculator? You need a calculator. Grab it. 6 factorial. All right. Do you guys know where your factorial button's at? Megan, go to math.
Okay, I was at
Okay.
math.
And go over to PRB.
Lenny, where's
PRB?
your
And all of your probability stuff is going to be.
X to
When I
the
get all these
negative
monies,
1,
Jace.
it's shift.
720.
You betcha. Yep. 720. Did you get 720? Do you know where yours is? Okay.
Guess
So
what's
yours is under the PRB button as well. So
No.
2. Okay, so we're gonna hit 6 first. And we're gonna do this
For
PRB
sales.
and all of your stuff. So these 2 buttons we're gonna use here.
Did you sell fruit?
But we're gonna go over
Yeah.
factorial. And 6 factorial.
You bring it?
720
Good.
ways. Yep. Yours is under right here. Okay, so you're just gonna hit 6 and you're gonna do that.
Wyatt,
Okay,
forgot
now
about
here
pair
in
of
just a
pants
second, when
house.
we need the
I don't think
NCR,
that's
you're gonna
good.
hit it twice. When we need the NPR, you're gonna hit it 3 times, okay? And hit that there. And then 720 different combinations. Do you know where it's at?
I can probably figure it out.
See where it's at? 6 PRB, go down, yep, you got it. Okay, yeah, you're on the right spot. Okay, 6 factorial, 720. So there's 720 different ways of just arranging those 6 people in different orders and such, right? 720 different ways. Okay, all right, so they do example 2. They say a statistics researcher must personally visit the presidents of these five places. 1, 2, 3, 4, 5. Yeah. Gallup, Nielsen, Harris, Pew, and Zogby polling companies. How many different travel itineraries are possible? So he could go like Gallup, Nielsen, Harris, Pew, and Zogby. If he wants to be not silly about this, he could go in order of distance, right? But he doesn't have to. He could go like this route. Doot, 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 doot. He could make a star, right? That's another combination, right, that he could do if he wants to make it really hard on himself. I don't know. Okay. How many different travel itineraries are possible? He will visit all 5 of them, right? So if I look at 5 different spots, how many places could have been visited in the first spot? 5. Then after he visits 1, there's only 4 that he could visit second. There's 3, third, second, first, whatever. And now we're multiplying all of those. And it's asking. If the itinerary is randomly selected, what is the probability that the presidents are visited in order from youngest to oldest? Yeah, that's trying to confuse you, and it's not confusing. Don't let it confuse you. There is only one combination of them standing youngest to oldest, or being in order from youngest to oldest. Only one combination out of the 120. So slightly less. You can leave it as 1 over 120, or it's slightly less than 1%. Good? Like 0.0 something. 0.009 or something like that, right? Okay? Good? All right, next thing. We have permutations and combinations. Have we talked about these before? Permutation, combination. Okay, permutation. There is an NPR in your calculator, and combinations, there is an NCR in your calculator, okay? And let's talk about what N and R are. It doesn't matter whether you're doing P or C. N is a certain thing, and R is a certain thing. N has to do with the total number. The total number. R is the number that we are choosing. Okay, so maybe I'm lining 6 of you up for a photo, but there's actually 2, 4, 6, 8, 9 people in this room, right? 9 people would be my N. My R would be 6. There are 6 of you out of 9, right? Okay. Now, if the order matters, right? Permutation, position, order matters. Put the word order here. Order matters. It would be a P. If the order doesn't matter, if I don't care where you're standing, no order. We would use a C instead. Let me use a different example. Okay, let's say I am choosing 2 of you. And one's going to be the president and the other one's going to be the vice president, right? Out of 9. Okay? President versus vice president. If I announce you, and I announce the president first and I announce the vice president second, does it matter what order your name is announced in? Are you going to have the same job if you get president versus vice president? No. So the order in which that matters, like the order matters. So I would do 9P2. Does that make sense to figure out the permutation? Okay, 9P2. I want to know which order. Because if I say Chloe first for president and Jack for vice president, that is not going to be the same thing as Chloe for vice president. Whoop. And Jack for president. So when it is counting the number of options, this will be one option. This will be a second option. Does that make sense? Okay. Versus when the order doesn't matter, these will be counted like as one, right? Chloe, Jack will be the same thing as Jack, Chloe, because it's saying that we don't care, right? What order they're in. When it's president, vice president, the order does matter. So I always see P and I think president, the order matters. Permutation, the order matters, so 9P2. What is 9P2? Do you guys know how to enter that into your calculator? What? 72? Okay, if you go 9 and you hit that P button, which is close to your factorial button, 9P2, 72. There are 72 different ways of ordering those. Okay. This, if I say, okay, now we're not doing president, vice president, we're doing like committees. So like Jack and Chloe are going to be on the recycling committee, right? That goes around to the rooms that recycles paper. That was the only committee I could think about. I don't know.
I think I
Whatever.
recycle.
What? You're coming to like my classroom to pick up my paper, whatever, right? Recycling committee, okay? So when they do that and they announce over the loudspeaker, like Chloe and Jack are on the recycling committee, does it matter that they said Chloe first and Jack second?
Nah.
No, because they're both doing the same job. So C for committee or the same job. If that is the case, we would do 9C2, and that would be less than 72. It is 36. 36 different ways. Okay? My case goes down like by half because they're saying that Chloe Jack is the same thing as Jack Chloe, so they only count it once, right? Versus if the order matters, those are two unique, different ways to count. Yeah? Okay. All right. Permutations. I'm going to stop after. We're going to do these next 2 and then we'll stop. We'll stop before combination. Okay, so in your calculator, you don't have to know this. You get the luxury of like not having to know this, but this is what your calculator computes when you put it in there. So n is the total number, n minus r is the factorial that you put on the bottom, and that's going to delete out the piece. And that's how your calculator computes a permutation. So example 3, in a horse race, a trifecta. Bet is won by correctly guessing the horses that finish first, second, and third, and you must get them in the correct order. If you win that, you get lots of money. Okay, you can do, I think you can box it. I think is what it's called, is like you put them in a box, right? So like you do the first, second, and third, and you box it, and that means that you got the first, second, and third in any order. That would be a combination, but which is not worth as much money if you win, right? Okay, so if you box it, it's not worth as much money if you win because they could have come in any order. But if you correctly guess the first 3 in that order, you win lots of money. Okay, the 140th. Okay, they're trying to confuse you with numbers. 140 means nothing in this case. That's a number that means nothing. Yes, correct. Mm-hmm. Okay, there are 19 horses. That's important though. What is 19? N. That's the total number. All right, R is going to be the number that I'm choosing, which is 3. And does the order matter? Yes, 19P3. How many different trifecta bets are there? Okay, that's not as big as I thought it was going to be. What?
I'm still trying to figure out how to do NPR.
Okay, you hit 19, and then go to your PR, go to math, go over to PRB, go down to NPR. Hit enter, and then hit 3 after it.
So I have 19 NPR.
3. And then 3. Nope, 3.
Good one. Throwing stuff around.
Okay.
Yep. Okay. Anybody else not figure out how to do that on your calculator? 19 NPR 3. Whoop. 58 14. All right, now B says if A better randomly selects 3 of the horses for a trifecta bet, what is the probability of winning if he selects California Chrome to win, Commanding Curve to finish second, and Danza to finish third as they did? How many combinations have those 3 in that order?
So one.
1 out of 58 14. What is that as a percentage?
Good Lord.
0.017.
0.017%?
Yeah. Yeah.
Percent?
Yeah.
Woo! That's even after we move the decimal. Wow. That's like way small. So if your chances of winning are that,
No, don't.
don't bet.
Why not?
'Cause that is bad.
Yeah, your chances,
Feeling pretty
I don't
lucky.
know. I don't know. Do all of the different trifecta bets have the same chance of winning?
I mean,
Yeah. Well. Yeah.
Yes.
technically,
If we're not looking at like quality of the horses and stuff or whatever, if we're not looking at stats, but yes, they will all be equally likely if all other things are the same. If horses, horses are equal quality, then yes,
They're all equal no matter the color, Tony.
sure. No, they're not. Hey, you know what? I got third at district livestock judging out of like 300 people because I judged the cows on how pretty they were. And I got third place. So I'm just saying, if you're talking about if you're knocking how pretty they are, whatever, and judging them by that, sometimes it works. So I'm just saying. Okay. All right. And then it does say ignore dead heat, switch the horse ties for a win, blah blah blah. Like they put that in there because if there was the possibility of a tie, that would complicate things, right? So
Yeah.
yeah. Okay. All right. This is another thing. Actually, you know what? I don't want to talk about him until tomorrow. We're gonna stop there.
Good.
Whoop. Stop above part 4. I will tell you what to do though. You should be able to do 5
5 and 7.
Sunday night.
and
7.
Because I don't want to take
in. Oh, but this one's in any order, so this one's a combination.
Yeah.
But can you do the combination?
Minor.
You can do 7, sure.
Think about it.
Can you do 8?
That's my excuse.
On the
You
way home.
can maybe do 8. Yeah.
Sleeping.
Graded in alphabetical order. If these examples are graded in a random order, what is the probability that they are graded in alphabetical order? Sure, you can try number 9.
But we didn't talk about alphabetical. It's just 26.
But how many combinations are in alphabetical order?
There's 26 letters.
One out of here is 6.
We're talking about 8 different stats exams. Right?
26.
Why didn't you tell me that?
Nope. Nope. First, find out how many different ways we can grade those 8 exams. Sure. Okay, so your professor has just collected 8 different stats exams, right? So there's like a few of you in here, like 8 of you, right? Okay, so I'm collecting those stats exams. If these exams are graded in a random order, what is the probability that they're graded in alphabetical order? Okay, nope. Nope. How many different ways can I grade the 8 exams? Does the order in which I choose them matter?
8.
Yes.
Now, you might not think that they matter, right? But like when they say the word different, how many different ways they're saying like grading them Megan, Jack, Averly, Jace, Delaney, that would be a different combination than other way around. So is this a P or a C?
I about fell. Calm
B,
down.
right? Okay. So you could do this as 8P8, right? I'm choosing all 8 to grade, right? Or 1, 2, 3, 4, 5, 6, 7, 8. I could grade 8 of them here, 7 of them here, 6 here, 5 here, 4 here, 3 here, 2 here, 1. Did you know that 8P8 is the same thing as 8 factorial?
Yeah,
Which is how many?
I just said it.
320. That's how many different ways you could
Choices,
grade
choices.
those things, right? Okay. Now, you might not think it matters, and it probably doesn't matter in the long run, like
No, it does.
which one you
Because
grade them in.
what if you're grading a lot and you get tired and you're just like, oh yeah, that's right.
I get into the habit of grading like the good handwriting first, and then I end up grading the sloppy handwriting last, and I'm like, why did I do this to myself? Because it gives me a headache at the end, and I'm like, why did I do this to myself, right?
What's the probability that they're
So, what is the probability that they are graded in alphabetical order? How many out of those 40,000 is exactly in alphabetical order? Only one. Does that make sense? Yeah. So, there are two.
That's a
No, there's only one answer to that. It's just the one out of 40,000. Yep. Does that make sense?
0.002% chance.
Probably.
Okay.
Was that one more or what?
I'm not very good at
Okay,
this stuff.
you can do 15 also. So, do the first page. The back page we'll save for tomorrow.
That was
Okay.
number 9.
Whoop, 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 whoop,
do
whoop.
19 and 20?
You can't, or you can?
Can.
You can. Okay, you can try it
Probably
if you want.
not.
I just was trying to.
I don't know about 22. I don't know what that
It was
is.
1 out of
Nope,
40,000,
you can't do 22 yet.
320 something?
Yep. Okay, so first page.
Megan,
There you go.
40,000.
All right, goodbye.
20.